Okay, so we're going to do number talk today. And when you know the strategy, remember quiet thumb. You have 2 strategies, 2, 3, okay? But make sure you use your quiet thumb, okay? So here it is. So 49 plus 52. So once you have your strategy, use your quiet thumb, please, to show me. Here we have a few people. Okay, let's start with you. What do you think?
So what I did is I took the 49 and I took the 52. I took 1 from the 52 and I added it to the 49.
So you took 1 from the 52.
Exactly.
So let's say here, and then you added it to the.
I added that 1 to the 49.
To the 49. So you did the 49, and you added 1 there. Okay.
Which equals 50.
Okay, so this equals 50.
Then I kind of like made that the 1 of the 51 like almost like invisible, and I added the 2 50s. Then I added the 1 back.
So originally you had 51. That's what you just said, right?
Yes.
And then you.
I almost made it like I couldn't even see the 1.
So you turned it into.
Yeah.
Okay, so you turned it into a 50. So you used 2 50s. Okay, and then what did you do?
Then I added the 2 50s.
So you did 50 plus 50. Okay.
And then I added 1.
And then you added 1. So you did 50 plus 50 plus 1?
Yeah. This is pretty easy.
Okay.
Which is 100.
So
And 1.
What's your answer, sorry?
101.
101. Okay, so 101. Okay, so did everyone understand his strategy?
Yes.
Okay. So it looks like you used from here. Does anyone know what strategy he used here? If you look at that, what do you think he used there? Yeah. Okay, so we used compensation here. So we call this compensation. Okay, because we're compensating when we take away, we're taking out 1, we're adding 1 back in, or vice versa. And then it looks like you also used a different strategy there. Does anyone know that strategy? Yes. Doubles. So you used doubling. Okay, so these are doubles. Okay, and doubles really help us because they're easy numbers to work with. Okay, and a lot of times we know what doubles add up to. Okay. Who has a different strategy they'd like to share? Yeah.
Would they be friendly numbers too? Because 50.
Yes, that's a good point. They could be friendly numbers because most friendly numbers are multiples of 10, and 50 is a multiple of 10, so it also works as friendly numbers. But because we're using the 2 same numbers, we call them doubles. Okay, so that's a really good strategy there. Who else has a different strategy? Yes, sir.
Okay, so I made the 49 a 50.
So you made this 49 a 50. All right, so I'll just put it right there.
And then I took the 52 and made it 50.
And then you just turned this 52 into a 50, okay?
Correct. And then I added the 2 together and got 100.
Okay.
And then I subtracted 1 from 100.
And why are you doing that? Why?
Because I added 1 to the 50.
So you're subtracting.
To the 49, sorry.
So you're subtracting 1 that you added to the
Correct.
49 to get your 50, okay, and?
And I got 99.
Okay, so 99.
So then I added the 2 that I took away from the 52 back to it.
So the 2 you took away from here, you're adding back?
Yeah.
Okay.
And I got 101.
Okay, so very similar to what was done here, except you explained it differently. Instead you went straight to the double this time, right? Okay, very good. Does anyone have a different strategy? Yeah.
I have a question.
You have a question? Yeah.
Can I show?
Yeah.
When he was doing his strategy, why couldn't he have, instead of subtracting the 1 here, why couldn't he just added 1? And then it's just 101 instead of doing like the -1.
That's a good question. So she's asking, instead of subtracting the 1, why couldn't you have added just the 1?
I was just trying, just for the strategy, I was trying to make them perfect. Like, just making them landmark numbers.
So you just put, are these landmark, is that a landmark number?
No, I'm talking about for the 50.
Just 50. So she's just asking, how come you just didn't add the 1 instead of subtracting and then adding that 2?
Adding 1 to which?
To the 100 to get your answer, your final answer.
Well, I could have done that too.
You could have done that too,
Yeah.
but why did you choose to not to do that?
Just didn't think of it.
You didn't think of it. This is how you thought of your strategy? Okay. Okay, so, okay, who else has a different one? Okay, and just let's name, who did name doubles? Yeah.
I did 40 plus 50.
Okay, so we just extend the page. So you did 40, I'm just gonna write it here on the side so we don't forget our numbers. So we have, no, sorry,
20.
52, sorry. So 52, okay, so you did 40 plus 50, interesting, okay, so you did 40 plus 50, okay.
90.
And that equals 90, okay.
And I added the 9 and the 2.
You added the 9 and the 2 here, so you did 9 plus 2, okay,
11.
which equals 11, okay.
And then I added 90 and 11.
So then you did 90 plus 11,
And I got 100.
okay, and how did you know right away it was 101? Was that easy to add for you? Why was that easy to add for you in your head?
I don't know, I just knew.
You just kind of knew? Does anyone think they know why this might be easy to add in your head? Yeah?
I think she probably thought because she knew what 90 plus 10 was, which was 100, and then she's, oh, it's just the
Okay.
extra one.
So 9 could, so you're saying this is, what is this then? How did you explain that number to me?
10.
10 as 10 and,
And then she probably just like added 1 in her head.
so we could say 11 is like 10 plus
1.
11 is like 10 plus 1, so that makes it real easy to add, okay? What strategy did you use here, do you know? Did anyone help her out and try to figure out, yeah? Place value, does anyone see how she used place value here?
Yes.
Okay, so we used the 40 and the 50 that you can see here, what's in our tens place value, and then she added up what's in the ones, is that correct? Right, and then at the end you added your two numbers, and then I like how what you did here with the 11 is you basically decomposed your number, you broke it up, okay? And that's a really great way to see a number, because you can see 11 in different ways. It can be 10 plus 1, it can be
9 plus 2.
9 plus 2, right? There's different ways that you can break up a number. Okay, of these strategies, which do you think would have been the most efficient? So we have this one. These two are very similar, the doubling and the compensation. So we have doubling, we can say this one's compensation, and then we have place value. Who can tell me which one they think is the most efficient strategy? What are you thinking here? Yeah, what do you think?
The third one.
So number 3. So I'm going to just go through, so let's just number these actually. So 1, 2, and 3. So you think number 3 was the most efficient? Why is that? How can you justify why you think this is the most efficient strategy?
The least amount of steps.
So because it had the least amount of steps. So that's one way we look at strategies. So you think when you have less steps, what does that mean then? Yeah?
You can do it faster.
You can do it faster. So and faster and efficient almost kind of go together, right? What else? Yeah.
I also chose number 3 because like using place value is easier like for me because I know like what Julia did, like 40 plus 50 is 90, and then the 9 plus 2 I knew was 11, so then 90 plus 11 was easy for me to just go, okay, 101.
Okay, so and what about the place value exactly makes it so easy for you?
Like the numbers, so for the 40 and 50, they're, I don't know what to call them.
They're like friendly
They're
numbers or landmark numbers? They're multiples of 10,
they're
right?
multiples of 10,
are
so
easy.
if, let's say it was 47 and 55, it would be harder for me to do that, but since it's 40 and 50, it's easier.
Okay. Let's do a little bit of a class vote then. How many would think that number, this side here, how many think number 1 is the most efficient of the strategies? Okay, interesting. How many say number 2, which is similar to 1? Okay, a few votes. Okay, okay. And how many believe place value is the most interesting? So a lot of you like to use place value. A lot of landmark friendly numbers there. Okay, good. Yeah, cut.